Now, a no start or starting issues will cost you big bucks with one of these rigs. If you're not starting, you're not making any money.
That's why we need to start right here at the battery, John. It's the heart of the electrical system, and we need to do a good visual inspection of this system and make sure we're in good shape. First, we'll just come down here, check our connections, look for any surface leakage across the battery, look at our cables, make sure it's not corroded. If you got a little bit of corrosion, get you some battery cleaner and clean up the battery and make sure it's in good shape. You know, there's some couple different tools you can use. Right here, the terminal cleaners. And once you get it all in tip-top shape, when you reconnect your battery, go ahead and put a little bit of dielectric grease on there so the connections will be good.
A couple more tips for you. Make sure the batteries are all the same manufacturer. Make sure they're all the cold cranking amps are all similar, and just make sure they're all in order. This semi has 4 batteries, so when we're testing these, we're actually going to take them out of parallel there, and we're going to go ahead and wire them up so we can measure them, each of them individually, and that's the key there. We got this one disconnected. We're ready to do it. The first one we want to do is open circuit voltage, OCV. Simply taking a DVOM, and we're going across the positive and negative, and when Chase goes across the positive and negative, we're just reading the voltage of the battery. This one's showing 12.8. Now that seems a little high. It's got a surface charge on it. Now that 12.8 is a good number. It's a good number to test the battery, but that doesn't mean the battery's good. We still want to do a load test because a load test is going to determine if the battery's good or bad, because we're going to have to draw the amps out of it to see if it can really give it that charge that we need. Now in order to do that, we have a load tester, and it's pretty simple. You want to explain the hookups?
Yeah, I got it. All right, what we want to do here is take our positive lead and go over the positive side of the battery first. Then we'll take our negative lead and go across the negative side of the battery here. All right, we got those intact.
Cool, and I got a amp clamp here. If you want to show them the amp clamp's actually going to go around the negative cable going back to the machine. And what is that doing? It's actually reading the amperage. As this machine is a carbon pile, it's going to take the amps out of the battery. So if you hook that on there, it's going to take the amps and it's going to read it as it runs through the cable going to the machine. Now to use the machine, it's really, really simple. We're just going to go through the prompts here. The machine is set up. This is an actual Sun 45. This is a carbon pile load tester. Well, what does that mean? Like I said, it's actually a big load inside of here that's going to draw that amps out. Just like you were using a starter motor or a wiper motor or anything on your vehicle, it's going to draw it out. And it's going to see if those plates have the capability to hold that charge, that nice deep charge that you want in this. So you can see right here, it's pretty simple to use. It's got the battery test, just hit yes. Once I hit yes, it says battery test in the vehicle right here. We're ready to go there. And then it wants the cold cranking amps. So you're going to have to identify that. Chase, what are our cold cranking amps?
Right here on top of the battery is a tag here that says CCA is 950.
Now be careful. If you're using an old VAT40 or some machine that doesn't calculate it by itself, you want to go ahead and take that cold cranking amps and you want to cut it in half. And you want to load test it for 15 seconds, and you don't want the voltage to drop below 9.6 volts. If it's cold, it may drop a little bit lower, but 9.6 volts is that threshold where you want that battery to hold for 15 seconds at half the cold cranking amps. Now our machine does it all for us. So if we just look and follow the prompts, I dial up 950 right there, hit yes. It says, do you want to start? I'm hitting start. Well, it's putting load number 1. We just mentioned that surface charge. We drove it in here, or the guy's been on the road for a while. The alternator's doing its job. It's charging on there. You could have 12.8 on there, but it's going to go ahead and take that off. And then it's going to put a second load, which is really going to get deep into the plates of those batteries and see if it can really put out that charge or that actual voltage and amperage that we need to run this system with. While it's doing that, I want to show you one other thing. Now, this is a conductance tester. Now, a conductance tester is an electronic tester. It's the same thing. You can hook it up. It just penetrates through the plates a little bit different. It's not an actual carbon pile, but it'll do the job just as well. But make sure you have one that's capable in 950 cold cranking amps, because that's a lot, especially when you're dealing with 4 batteries.
Definitely. If you got, 12.6 volts, but you're not getting that amperage, I mean, you could have a bad battery. We broke all these batteries apart so we can test them individually, and that's super, super important. How we doing over there, John?
It's done. It says battery's good. It's already recovering, 12.4, 12.5. It's coming back up, so our batteries are in good shape. We can turn our attention to the starting system. Now, if you have a starting system, a couple of tricks. You can use a headlight test, basically. You can just go in there and you can crank the vehicle, turn your headlights on. If you crank it and your headlights stay really, really bright, perhaps you have an open. Maybe you're not getting anything even to the starter whatsoever. Or if you go to crank it and the headlights go really, really dim, maybe it's some mechanical resistance. Could be a dead battery, or you just get those clicking sounds. When you go to click it, it could be a solenoid issue. But we're going to dive into the starter. We're going to look at some voltage drop methods with the starter before we actually go into the system and actually look at some of the load testing. Now, checking resistance on a starter system is crucial, and we're going to do it with a method called voltage drop testing. We're not going to use resistance, we're going to check voltage, run some amperage and volts through the system in order to check for resistance. It's pretty cool. But before we get started, check this out. We actually have the starter located right here, just like on the semi, coming over with the negative cable over here to the ground, and the positive cable over to the solenoid, exactly what you would do. So if you were doing it on the truck, you would do it identical to this right here. And what I'm going to do is I'm going to use a load tester to go ahead and pull the amps through the system when we do the voltage drop. The first thing I want to do is I want to take the load tester and I want to hook it up to the positive side here to the solenoid. And then I want to ground it to the starter. Now I can ground it to the housing of the starter, but I'm going to put right here on the ground terminal, which is great. And we're going to measure the voltage drop of the positive and the negative side. So in order to do that, I'm going to come over and I'm going to switch my meter to volts, DC volts. Now the unique part of this is I'm going to take the leads and I'm going to hook them up from the positive to the positive. That's right, positive to the positive. So I'm coming on the positive cable here. If I get it on the positive cable, I'll just go right on the solenoid, and then I go across the positive on the battery. So I'm going from positive to positive. Well, our meter's not showing anything, but it will once we add the load to the circuit. So I'm going to go ahead, I'm going to dial up my load. I'm going to put about 100 amps in this circuit here. And when I dial it up to about 100 amps, you can see I have about a little over a tenth voltage drop. That's fine on the positive side. The positive side, you can have about 3/10. The negative side, you can have 2/10, which equals about a half a volt voltage drop. Once you get past that, think about it for a minute. My starter's not getting full voltage. Number one, you're damaging the starter. Number two, your pinion may not work right. It may not engage here with the solenoid because of the low voltage. You're going to have a lot of issues. So voltage drop is critical to get the proper voltage to make sure your starting system's operating properly. Now, just as important as the positive side is the negative side. So what I'm going to do for the negative side, I'm going to keep it in DC volts. And what I'm going to do is I'm just going to take the leads and I'm going to go from the negative here over to the battery negative. That's right. Once again, negative to negative. Now we're showing nothing once again because I don't have anything going through the system. So if you're doing it on the truck, you want to have the truck running to do voltage drop. All right. I'm going to come over here. I'm going to simulate the truck running, run some amps through the system. Get it up to about 100, even a little more there. I can zap it. Barely getting a tenth. That's really good on the negative side. Now, if I had a voltage drop of over a tenth or half a volt, what's causing that? Well, it's caused by resistance. Well, what's resistance? Well, we can look at a couple demonstrations I have down here for you. And you can see what causes resistance. Wires, the length of wire, the type of wire, where the wires ran, all this right here. Now this is great for a house, but this doesn't work on a car. It's not flexible enough. It's not going to do the job. Right here we have some heat. You start introducing heat into the system. You run your wire, especially a starter wire. This thing could be carrying 600, 800, 900 amps of electricity to one of these massive starters. I start introducing heat in there. That's going to restrict the flow. That's resistance. I lose amperage. I lose my starting capability. Then I come over to the crimps. Okay, if you have any wires, even going to the solenoid side, even on a start wire, if I have some bad crimps like this, I start having some issues, you're going to have some problems. All right. Now, why do I use voltage drops? Because let me show you. If I switch back to resistance, I'll show you exactly why. And this is pretty cool. I can go across this front cable here. And when I go across this front cable, I'm checking resistance now. So right now I have 0.1, okay, 0.1 ohms of resistance, nothing, I mean virtually nothing. Now if I come over to this wire, it's all cut up and I have this little piece right here. Well, what's the resistance going to be? Well, you think it would be super high because I don't have any wires, but in reality, I have the same thing. It's 0.1, a tenth of a volt running through there because there's a connection. But you know what's not running through there? Amperage. We don't have any pressure, electromotive force, nothing running through those wires. I need to have the amps pumping. If I started to pump some amps through here, it turns into a fusible link and burns. Another thing you want to think about too is the contacts. Okay, so once I do the voltage drop of the starter system, you may want to take it a couple steps further and go from the solenoid down to the motor terminal. What is that checking? It's checking the contacts right here. And what happens in a starter motor, when you turn the key, I energize the solenoid. And when I energize the solenoid, this plunger comes out and it makes a contact between these two terminals. Well, loose terminals, if you don't torque these to specifications and these things are wobbling and not right, I'm not making a good contact. If I'm not making a good contact, voila, burnt terminals, just like that. Well, what's that burnt terminals going to cause? Resistance. Once again, resistance lowers current and voltage. Once that current and voltage gets lowered, starter can't do its job. Speaking of resistance, Chase, you actually got a wire. If I was to use that wire, I don't think we would do too well.
Probably not, John. Let's go ahead and put this in replace of our big bat wire here.
So if I take the bat terminal off, now you don't want to do this at home, but we're thinking that if we used a little tiny wire, which we saw done before, we saw little wires like this, or wires with bad condition, wrong type of wire, or even loose connections like this. If I put this on the battery, which I don't even know if I can, there we go, we got that on the battery. Now hold on a minute, because what's going on is we're going to try to pump a massive amount of amps. You may have to dial this thing up to 500 amps, but once you do it, what do you think is going to happen? Go ahead, juice it, dial it up. There it goes. Oh boy, look at that, look at that, look at that, look at that. Woo, okay, that's good. Man, that's perfect.
You sure don't want that happening.
No, you don't want that happening. That's a perfect display of current running through that wire and resistance not making it. It's a ginormous fusible link. So you know what you want to do? You want to make sure you use voltage drops every single time. You want to make sure, like Chase did earlier, you want to make sure you do a good visual inspection, make sure all your connections are good, and you're never going to have a problem.
That's right, John. You know, these are some really awesome tests. You know, big rigs like this, if they're not rolling, no money's being made.
Yeah, you can troubleshoot any starter now.